Here's a nice payoff of having built Quart Feed on top of the counter app. We didn't just inherit its structure, we inherited its tests. Look in the tests folder and you'll still find the counters conftest.py and a test counter.py. That conftest.py with its fresh database fixtures is exactly the harness we want. We just have to point it at Quart Feed instead of the counter. So rather than write testing from scratch, this lesson adapts what we already have to cover registration, login, profiles, and following. Start with conftest.py. The fixtures that spin up a throwaway database and hand us a test client need no changes at all. We make just two adjustments. First, Quart Feed's forms carry a CSRF token, and we don't want to fetch and echo tokens in every test. So we add WTF_CSRF_enabled set to false to the config the fixture yields. Second, our fixture builds the tables with metadata.createAll, which only builds tables it knows about. So we import the models we're about to test to register them. The three fixtures are the same ones the counter app gave us. Create DB drops and recreates an underscore test database, builds every registered table, and yields a config dictionary to which we've now added testing and the CSRF flag. Create test app feeds that config into create app, and create test client hands us a Quart test client. The one detail worth remembering is that the client keeps cookies between requests, which is the whole reason we can test logged in behavior at all. While we're in the tests folder, delete the counter's old test_counter.py. It hit / and checked for counter1, but Quart Feed's homepage is a feed now, so that test is obsolete. That obsolete counter test taught us a useful shape though, and we'll reuse it for the real features. Make a request, assert on the response, and verify against the database. Create tests / test_user.py, starting with registration. The first test is the smoke test. Ask for the registration page and check that the word registration comes back in the body. The counter test asserted the count went up. Our equivalent asserts a user was created. A successful registration answers with a 302 redirect, so that status is our first signal. But a redirect alone proves little. So test_register_ creates _user opens the database directly, just like the counter test read the counter row and confirms Alice exists with a password that is not the plain text we sent, which quietly guarantees we hash passwords. The last two tests push the unhappy paths. Registering the same username twice surfaces user already exists, and an empty form comes back with this field is required, proving validation runs before we ever touch the database. Next, add the login and logout tests to the same file. This is where the test client's cookie jar earns its keep. We register, then log in, and the session cookie set at login writes into the next request automatically. After Carol logs in, we request the home page and check we land on the real feed, the page that says Quart Feed instead of being bounced to log in, which proves the session stuck. The two failure tests confirm a wrong username and a wrong password. Both return the same invalid username or password message, which is deliberate. We never tell an attacker which half they got right. And test logout runs the round trip in reverse. So once Erin logs out, asking for the home page redirects her away. Exactly what we want for a page that requires a login. The last piece of the single user story is editing a profile. Add these tests still in test user PY. Renaming yourself is trickier than it looks because the username lives in the session too, so we check both the database and the session. Test profile edit requires login locks the door. An anonymous visitor gets redirected to /login, and we assert on the location header to be sure. The rename test is the interesting one. We follow the redirect so we see the updated profile page with the new @Frankie handle, then open the database to confirm the row moved from Frank to Frankie, and finally peek inside the session with session transaction to prove the session now carries the new name. The last test guards an edge. Saving your own unchanged name is fine, because a user should always be allowed to keep the name they already have. So far, every test has used a single client, but following is a two-person activity, and one cookie jar can only hold one session. To test it, we spin up two clients from the same app, each with its own session, so Alice and Bob can act independently. Create tests /test_relationship.py. We start with the imports and a small helper. The helper registers a user and then logs them in for whichever client we hand it, so each test below reads as a story instead of a pile of form posts. Notice we ask create test app for the client ourselves with create test app test client, once for Alice and once for Bob, instead of using the shared create test client fixture. Now each user has a real separate session, which is what following needs. The story reads cleanly. Alice follows Bob. We open an app context and we look straight at the database instead of trusting the page. The relationship table has exactly one row. Then Alice unfollows. We run that very same query again, and this time it comes back empty. The row is gone, which is the whole point of the unfollow route. The second test checks the guard. An anonymous follow with nobody logged in bounces to log in, so we assert on the redirect, and on the location header it sends back. The last test reads the page the way a visitor would. We set Alice and Bob up again, and then before any following has happened, Alice loads Bob's profile and sees a follow button waiting for her. Then Alice follows Bob, loads that same profile again, and the very same button now reads unfollow. The page told us the truth both times. Run the whole suite with Pytest and watch it come up green. We started from the counter's inherited harness and grew it into a real user feature test suite. From here on, every time we add posting, the feed, comments, and likes, this suite quietly stands guard over the user layer, so a change 3 lessons from now can't silently break login.